Hello guys, we are back with our next lecture. In this lecture, let us go through the flowchart of a genetic algorithm, guys. So one of the most interesting algorithm according to me, guys. I don't know how you are feeling, but this is one of the most interesting algorithms you can say, because you are going to understand how in the back end the things are going on. So I'll be explaining you in that much detailed, guys. Okay, this algorithm. Okay, yes. So let us go through the flowchart. Initially, let us go through just the outline. Then I'll be going inside each and every step, guys. Like I'll be showcasing you how exactly everything is done. Okay, so in that much clarity I'll be showing you. So just wait. Okay, yes. So let us start. So basically the first step is you will be starting. Okay, so once you start, you will be selecting some initial population. Guys, please understand the terminology, guys, because in examination, if you write the way how I am explaining or which words I am using, it might not be a good practice. So it is always better to write the words which are in the book. So I'll be using population only, but if I am using any kind of funny terminology, please don't use it in your examination. Okay, yes. So the first step is nothing but you need to initialize a population. So basically your question will be, so what is this population now? So first of all, only you are just giving you some words, you are thinking in that way, right? Yes. So it is really simple, guys. So whatever input we are giving, okay, so that input is called as population. Okay, so basically we are not going to give a single input. You'll be giving 2 or 3 or 4 or 5 or 10 inputs. So all those inputs combinedly called as population. Okay, so this population might be user defined, or in some situations you can select it randomly. Got it? Yes. So you can select it by user defined. So basically if you ask me, I'll be giving some inputs. So you will be checking whether they are perfect or not, and you will be optimizing them to the best results. Okay. So that is population. So now you got idea about population, right? Yes. So the next, once the population has been selected, you will check the convergence. So your question will be, what is this convergence now? Okay, so if I give some input based on the problem, you are solving something, right? So you are getting something in the optimized way, right? Yes. So this convergence is nothing but to check whether you reached the requirement, you reached the threshold percentage or not. So that thing is nothing but convergence, guys. I'll be explaining you with respect to theory and with respect to an example in detail, so don't worry. Okay, so that is some check condition. So basically, did we reach the required solution? Yes or no? If yes, you can stop, else please repeat a process. So the repetition is nothing but the first step is selection and the second step is reproduction, guys. So in selection, you will calculate each fitness value. Okay, so what is a fitness, guys? So basically if someone goes to gym, he is a bit fit, right? Okay, so if a person who is not going to gym, he is not fit, right? So in that way, okay, so in that way you will be checking whether this solution is good or this solution is good. So which is better, you will select that, guys. Okay, so you will select two important solutions or the two best solutions, and you will perform a mating between them. Okay, once you mate both of them, you will get a single result, or sometimes you might get two results. So among these two, you will select the best one again. Okay, okay, so before selecting the best one also, you will do some more operations, guys, after selecting the first one. Okay, yes, so you will do two processes, that is nothing but crossover and mutation. So at the end you get one result, right? So you will add that into your population. So if your previous population is size 10 and you are having the 9th one, which is the worst case, so basically even if it is not giving any kind of, if it is not satisfying any requirement, so in that situation you will replace that 9th one with our new one, and you will again check the convergence. So you will continue this process until you get the best one, guys. That is the logic here. So it sounds really interesting, right? So now I'll be taking an example and I'll be showing you exactly how it is happening. So the first request that I am asking you is, please draw the diagram somewhere, guys, first of all, because as I am explaining you on in the theory part, you will understand why I told you the details clearly. Okay, yes. So let us start with an example. So I'll be taking 0/1 knapsack only as the example. So it is really an interesting problem, right? Yes. So the initial weights are given in this way. So we are having 3 items. Each item is having some weights and profits. So our goal is to, in the maximum weight, you need to get the maximum profit. So you can store up to 25 kgs in your bag, but you want the maximum profits, guys. Okay, yes. So let us start. So the first step is, you need some population, right? So once we start the genetic algorithm, we need initial population. Okay, so initial population are nothing but encoded input data. If you don't have, take something random, simple. So basically your question will be, so what is this encoded? Okay, so encoded is nothing but, so in genetic algorithm we basically use a binary encoding, guys. So instead of storing in numbers like 15, 10, 5, we'll be storing in terms of binary. Like if it is a 5, it is indirectly 1 0 1 0, right? So 2 power 0, 2 power 1, 2 power 2. It is 1 plus 0 plus 4. So in total it is 5, right? Yes. So in that way you will be storing the weights, guys. Got it? Yes. So in that way you will be storing. Okay. Yes. So here instead of making this much complexity, we used a small trick. So basically instead of using that, so we took some values, guys. So basically here in bag we are taking, in first option we are having 4 populations, guys, in total. So sorry, we are having one population with the 4 chromosomes, you can say. So in genetics we use, right, so chromosomes, mating, genes, these terms. So we'll be using the same terms here also. Okay, so we are having a population. Inside that population we are having 4 chromosomes, guys. So the first chromosome has only one A. Okay, so only A. So in second chromosome it is a AB combination. In third chromosome it is AC, it is BC. So what are these things is your question, right? So I am carrying in bag only A is first case, only AB is second case, only AC is third case, and only BC is last case. So here I gave the inputs, right? Yes. In the same way, so this is one possibility, or you can take it randomly also based on your input. So if input is given, you can take it directly or you can take it randomly. Okay, so any one option you will be taking. I'll be following this taken by me, guys. I took that directly, so I'll be taking them. So basically if you want to draw the population diagram, it will be looking in this way. So inside population we are having some chromosomes. These chromosomes are nothing but these. Okay, and each chromosome having some values, right? 1010, those are genes, guys. Okay, yes. So you might be having it out. So how did I write this 101s, right? So whichever item I am carrying it to 1, guys. Whichever item I am not carrying, I'm placing zeros. That's it. A simple logic, right? Yes. Okay. So now you got the population, right? So you started, you got the population. Your next question will be convergence. Okay. So once the population is ready, we check for convergence. Okay, so in knapsack, what is our goal, guys? So we can carry a maximum of 25 kgs. We need the maximum profit is our goal. Okay, here we can manually check if any mentioned population satisfies it. So basically in convergence we are having multiple methods to check, guys. So the first method is you are going to manually check. Okay, so this value is giving this much weight, it is giving this much profit. Is it the maximum best? In that way you as a human will check, guys. Okay, so that is the first method. Or compare the profits and decide whether to generate a few more populations or to stop. So you will check and you will decide whether the profits which you are getting is enough, or you want more profits, or you want to check whether there is any other possibility. Okay, so you will be doing it, any one of them. Okay, or you can generate few more populations like iterations. So basically you will say that, okay, let it be, I'm not interested in checking, let me generate some more best options. Okay, so remember one more thing. So whenever you perform an iteration, you will always get the best results, guys. Okay, yes. So what is the logic you say? Okay, so assume that you are mating 2 persons or 2 items which are having good qualities in them. So mostly the result will also have good qualities, right? Okay, okay. So if you are not going to take wrong meaning, I'll be saying you in a normal way. So basically if someone's a mother and father, if they are in a proper way, like if they are good and if they are having some habits, so those habits, like they might be good habits or bad habits, will automatically be coming to their children, right? Yes. In the same way here, whatever the genes or the chromosomes which they are having, the best ones will always result in the best child, guys. Okay, yes. So here instead of calling child, we will call him as offspring, guys. Remember the terminology, guys. Okay, yes. Okay, so based on that you continue the iterations. Okay, so the simple thing is based on the problem criteria. So we decide whether our final solution is in population. If yes, we will stop. So basically if we reached our goal, we will stop, else we will generate few more chromosomes. Note, when a new chromosome is produced, we replace the old worst chromosome. So basically which is having the worst situation, we'll be taking that chromosome out and we'll be placing the new chromosome. That's it. Got it? Yes. Okay, so assume we want to generate one more chromosome. So here if I stop, there is no understanding of the next steps, right? So that is the reason why I want to continue. Okay, so the next step will be your selection phase, right? So in selection phase we are having 2 steps, evaluating and selecting the mates, right? Yes. Okay, so here we always select the best to generate the next best of all. Okay, so basically you are going to select two best parents, you can say, to get the best children or the offspring. Okay, so in our case we are calculating the profits, guys. So without my notice, I took the exact case which is 100% satisfiable, right? So we know that that is an value which is the maximum one, right? So anyway, just avoid it for now and assume that I am taking these two as the best parents, right? So these are the two maximum parents which we are giving 300 rupees and 350 rupees, right? Yes. So hence we selected these two, we evaluated. So this step, like I calculated each and every one, right? So that step is nothing but the evaluation of fitness. So and I selected the two members, right? The two best ones. That is nothing but the selecting mates. Okay. So the next step is reproduction. So in reproduction, we are having two steps, guys: crossing and mutation. Okay, so now let us go through crossing. So from the name you might get some meaning, but you will not get clear idea, guys. So I'll be giving you an example. So crossing is nothing but, okay guys, I'll be giving you the example definitions of a crossing, selection, mutation, and all those things in the next lecture, guys. Okay, so for now let us understand the concept first of all, because concept is important than definitions, right? Yes. So assume that we are trying to do crossing. We are trying to do a single crossing. Okay, so assume that our inputs are 0 1 1 0 1 0. Similarly, our second parent input is 1 0 0. Okay, so if you want to perform a crossing in between them, okay, so let me divide them into cells. Okay, so let me take some other color pen. Okay, so if you want to perform crossing in between them, so first thing is there are multiple ways of crossing, guys. So the first type is single crossing. So here you draw a single line somewhere. So you might draw it here, you might draw it here, you might draw here. It is completely random. Okay, so assume that I draw it here. Okay, so once you draw it here, so you cross in between them. So you might be saying that what is the term crossing, we are not getting, right? Yes, so you might be thinking in that way. So crossing is nothing but write this 1 1. So once you reach this line, switch to the next one. So write these guys details and again start from here. Once you reach the line, write above one's details. So alternatively, you will be writing this as one child and this as one child. So child is nothing but the offspring, guys. Please remember the term offspring. Okay, yes. So these are your new offsprings. So among these two, best one you will select. Okay, and you will continue. Okay, yes. So if you are drawing a single line and mating them, that is nothing but single crossing, guys. So here I am taking this as one pair and this as one pair. Similarly, we are having double crossing. Okay, so I have drawn the diagrams also for us to understand. Similarly, 2-point crossing. It is nothing but I will be drawing two lines and I will be taking alternatively. So this parent will start from here, here, again up here. So 0 1 0 1 1 0 is one parent, 1 1 1 0 0 0 is other parent. Similarly, multi-point. Here I will be drawing multiple lines, 100 lines, 200 lines based on the input size. Okay, so I will be taking it. Okay, so this is all about crossing. So similarly, we are having few more crossings. Okay, so the next crossing is uniform crossing, guys. Okay, so using a random toss coin. So basically you will be taking a coin and you will be flipping it. So based on what you are getting, so you will be saying head is 0 and tail is 1. So based on the input, so if it is a 0, you will not do any swaps. If it is 1, you will swap in between them. Okay, so assume that your toss sequence is this: 1 1 0 1 1 1 1 0 0. So you will swap these two. So 1 0. You will swap these two: 1 1 0 1. These three are 0. So you will be taking the same values. Got it? Yes. Okay, so the other one is using cross mask. So instead of tossing a coin, you will have a mask, just the predefined values, you can say. So based on these values, you will perform the crossing. Same concept. Okay, yes. So among two children output, we select one which is not already in our list, or randomly, and move to the last step. So basically from these two, we got two results, right? So there is a high chance that any one of them might be already in our population, right? So why to take the same one again? So we'll be selecting the other one which is not there. Got it? Yes. Okay, so then we'll be moving on to mutation. So mutation is also a random replacement method, guys. Okay, so here we perform some random replacements. So basically it is 100% random, you can say. Okay, yes. Okay, so basically our offspring is this. So we got this result and you will be having a mutation probability value, guys. So this value you will be taking it randomly or using some kind of a coin flip or something. Okay, so once you have the mutation probability, if it is 0, you will not swap it. So basically here flip is nothing but you are going to complement it. So basically if it is a 1, I will complement from 1 to 0. Okay, so if here it is 0 0 means no change, and again here it is 1 and here it is 1, so I'll be making it 0. So whenever here we are having a 1s, we are going to complement that values. Okay, so that is nothing but the first way. okay, using mutation probability. Okay, so using interchanging, so basically this is a second way of performing mutation. So here you will select two items and you will just interchange their positions, guys. Okay, so any way you do, the final goal is to get the best solution, guys. Okay, so now replace the mutation springs in the worst case. So basically if I got this as the result, I'll be placing this in our population in the best place, sorry, in the worst place, and I'll be replacing it. Okay, yes, and you will be again checking the criteria again. So you'll be checking the criteria and you'll continue. So you will stop whenever you get the final solution. I think everyone got a clear idea about the whole concept, right? So if you are still a bit confused, please watch the video again, guys. Even though the video is 15 minutes of length, but you are going to 100% have a clear idea of the whole genetic algorithm concept, guys. You are now done with genetic algorithm operations and its applications. You're done with 3 topics in a single video, guys. Okay, yes. So I hope everyone got some basic idea. So in the next lecture, let us go through the exact definitions of which you should write in your examination. Okay, yes. So let us meet in the next lecture. Thank you. Thanks for watching.